Hi everyone, welcome to Trig Identities Notes Day 3. So in this video, we're going to talk about some new identities called the Pythagorean identities. We have 3 different ones that represent the identities, and I'm going to show you how we got each equation. Starting off with our first one, sine squared times cosine, or sine squared x plus cosine squared x equals 1. Well, remember the Pythagorean theorem we learned was x squared plus y squared equals c squared r squared, doesn't matter. Okay, and because we've been working with the unit circle for so long, we know that sine represents the y values of our points on the unit circle and cosine represents the x values, and the radius of our unit circle is 1. So that should make some connection to the unit circle. But if not, we can always look at a triangle right here. So if we look at it, my x distance is represented right here. My y distance is my vertical distance. And my radius, my r, would be right here. If we let our radius equal 1, and this right here be our angle, then we could say that sine of our angle, let's name our angle theta. Sine of our angle theta is equal to opposite over the hypotenuse. My opposite is y, my hypotenuse is 1, which means sine theta equals y. Okay, and then I have cosine theta, which is equal to adjacent over hypotenuse. Adjacent is side x. The hypotenuse is 1. And that's telling me that cosine theta equals x. So if I plug that into the Pythagorean theorem, it gives me sine squared plus cosine squared equals 1. Okay, so that's how we get the first one. Now, the other two come from doing operations on this original Pythagorean identity. So I'm going to show you how we get those. Okay, so we have sine squared x plus cosine squared x equaling 1. So to get this middle identity, what we're going to do is we are going to divide both sides, or everything, by cosine squared x. Cosine squared x. So what we learned from our quotient identity is that sine over cosine is tangent. So if I have sine squared over cosine squared, that equals tangent squared. Cosine squared x divided by cosine squared x is just 1. And 1 over cosine squared is secant from our reciprocal identities. And now you see how we get tangent squared x plus 1 equals secant. Looking at the last one, so again, I'm going to take my original sine squared x plus cosine squared x equals 1. And now, instead of dividing it by cosine, I'm going to divide it by sine squared x. Divide each term by sine squared x. So when we do that, sine squared x divided by sine squared x is 1, plus cosine squared over sine squared is cotangent. That's our other quotient identity. And then another reciprocal identity, 1 over sine squared x is cosecant squared x. And that's how we get all 3 of our trig identities. Now, not only do we need to know these 3 identities, we also need to know the identities if they are rearranged in any way, shape, or form. Meaning, on the first identity, sine squared x plus cosine squared x equals 1, I need to know that if I see cosine squared x, that is the same thing as 1 minus sine squared x. Okay, I also need to know that sine squared x is equal to 1 minus cosine squared x. So you have to be able to manipulate the equations and solve for different parts and know that that's still a Pythagorean identity. Same thing goes with tangent squared x plus 1 equals secant. So if I see tangent squared x, I need to know that that is equal to secant squared x minus 1. Or I need to know that tangent squared x, let me rewrite that. Let's do 1 is equal to secant squared x minus tangent squared x. So again, needing to know that those are the same thing as the one above. So not only do we have just 3 main ones, but you have 2 different versions of each main one. So that makes 9 identities, but 3 different ones, okay? And then here, we need to know that cotangent is equal to cosecant squared x minus 1, or 1 is equal to cosecant squared x minus cotangent squared x. So again, knowing that these identities are all the same, no matter what form they come in, is going to help you be better at these identities. So we have 3 examples that we're going to verify. So again, we start with the left side, trying to make it equal the right side. Okay, so right here I have sine x times cosecant x minus sine squared x equals cosine squared x. Well, I still want to write things in terms of sine and cosine. So I have sine x over 1 times cosecant x, and cosecant x is 1 over sine x, minus sine squared x. We don't have to worry about that. So we see that my sine x on top cancels a sine x on bottom, and that leaves me with 1 minus sine squared x. Well, as I told you before, we do need to know the identities when they're solved for different things. And 1 minus sine squared x is equal to cosine. And that's what we wanted to prove for this example. Again, we want it to equal cosine squared x, and it does equal cosine squared x once we solve or simplify. Okay? Moving on to the next one, we want to prove or verify that secant squared x minus 1 divided by secant squared x is equal to sine squared x. Okay? So again, writing everything in terms of sine and cosine is usually very helpful. But right here, we need to double check, is that an identity? Secant squared x minus 1. Is that an identity? So we go up to our identities that had secant. And if we look, secant squared x minus 1 right here is equal to tangent squared x. So what we're going to do, instead of writing it in terms of sine and cosine right now, we are going to identify it as tangent squared x and use that to help us simplify. So we have tangent squared x divided by secant squared x. Now that I have it simplified like that, now I can rewrite it in terms of sine and cosine. So tangent, going to keep it in green, is going to be sine x squared over cosine squared x. And I'm still dividing it. And now I'm going to fix secant squared x and say it's 1 over cosine squared x. Now, again, we don't like dividing fractions by fractions, so we do our keep, change, and flip. So sine squared x is going to stay the same over cosine squared x. We are changing to multiplication. We are flipping 1 over cosine squared x to cosine squared x over 1. We simplify. Cosine squared x cancels out cosine squared x. It leaves me with a sine squared x, and that is what I want it to equal. So I've proved and verified that the left side equals the right side. Okay, moving on to our last example.